So let's just continue with the example section of the ultimate limit states. We do have a couple of examples which we're not going to go through, but I'll just show you the system for the example 5, which is also shown in example 3. So example 3 is just continuous beam, which does have the same issues as example 1. We should check the shear and the moment and also the support, which means the compression perpendicular to the grain. What we are going to look here in our next example are the columns. So we do have two types of columns. We have an inner column and we have the outer columns. These ones are shown in example 5. So we have two types of loads, the loads for the inner column and the outer column, which is shown here. And both of the columns have different kind of sections, and they also have different kind of buckling length, both for the lateral torsional buckling and the usual buckling length. The definitions for both columns are given here. So we can just start with the first one, and I have called those example 5a and 5b. So we're going into this subdirectory, and we do have Limtreboka example 5a, which in that case is inner column. This is in Norwegian is inner søyle. The definitions for the inner column, if we go back to the example, as always, the left hand side shows the example, the right hand side shows the calculations. Then we have the inner column shown here, the midtsøyle. The inner column has a length of 5,685 millimeters, and point A, which is the connection between the beam, the roof beam, and the column, is 5,685. This is stabilized in the horizontal direction. So there are those two types of columns. We have the possibility, we have the 6,900 millimeters, which is the buckling length of the first system, and 5,685 millimeters, which is the system B. Well, the 6,900 goes to the top of the beam and 5,685 goes to the bottom of the beam. So depending on if this is stabilized in the horizontal direction, you get two different buckling lengths. So in the next kind of calculations, you're going to check different type of systems here. So if we go back to our calculation sheet in Maple, we put in the width and the height of the system, which is of the column, which is 190 millimeters and 675 millimeters, strength class of GL30C, service class 1, and a short time duration class. So the buckling length here is defined as 6,900 millimeters, which means to the top of the beam, and the same applies to the lateral torsional buckling. We are not going to have to check the supports in that case, because we're not checking the beam but the column. Compression at an angle to the grain is not interesting either. No varying cross sections, and we don't have any end-notch beams. So in that case we have just one load case, which is the ULS, the ultimate limit state, and this one is defined as by 718 kilonewtons. The force is also in the direction of the grain, so we have a 0 degree alpha value here. The calculation is done automatically again. We have load case ULS, and this one shows that the formula 632 is the one dimensioning this system, column subjected to either compression or combined compression and bending. In that case, the utilization is 1.13, which is above 1. That means that the section has not enough capacity. So going into the detail section again, we have those values KH and KHB. The 6.1.4 has an utilization of 1.13, and we do have the stability of the members with the lambda relative y 0.5 and in sets 1.91, and KCY and KCZ, which are those values, and the other ones are self-explaining more or less. So going back to the calculation example, we do see that if we are using the connect length, the longest buckling length, by 6,900 as we have put into, also that calculation shows a utilization factor of 1.1. So we can also have a quick look at the second example. Which is the outer column. This one has a different section and a different buckling length. As you see here, there are two different buckling lengths. The one in the main direction is 5685 millimeters, and in the weak direction it is much less. The same applies also to the lateral torsional buckling. And in that case we do have different cases. So we have the case where we just have a vertical load by 235 kilonewtons, which gives it a utilization factor of 0.17. And we also have the combined snow and wind situation where we have normal force and in addition a moment on the section. In this case we do have the combination formula for columns subjected to either compression or combined compression and bending. Again, you do have the stability member factors and the combined results for each of those calculations. So that was this example, and we are going to continue with the next example in our next session.